Hey everyone, Jake from Enve Composites here to talk to you today about a new category to Enve, which is road tires. So we recently launched the SES road tires. It's a complete collection of tubeless compatible road tire. A little over a decade ago, we began our aero rim development, which is known as the Smart Enve system, or today referred to as an SES category wheel. What we found early on is that tires have a major impact on the aero performance of a rim. And so what we saw is as rim shapes continue to be refined and ever more refined, you get diminishing returns in terms of what you can actually do with the shape of the rim. And what it leads you to is when you're looking at how to improve or further improve the aerodynamic performance of the wheel, you have to look at it as a system, which led us to tires. And so the new SES road tires are developed for aerodynamic performance. That is one metric upon which they're measured. The SES road tire will add about a watt aero advantage over other tires available on the market, or at least be on par with the best-in-class aerodynamic tires on the market, because ultimately aerodynamics are only one factor that you need to consider when you're looking at a road tire. As I mentioned before, the SES road tires are tubeless compatible as well. Tubeless has been a big initiative for Enve. The reasons for that have been because it ultimately delivers a better ride experience. You get better traction, can achieve more comfort, better rolling resistance, and more flexibility in terms of tuning your tire pressure to how and where you're riding. And so given that not all of us ride on the same surfaces or with the same kind of style, it's important to be able to tune your tire pressure. And if you have to run a certain pressure just to not get flat tires, for example, then you don't really have the ability or the control to fine tune your ride quality. These tires give you that opportunity, or give you the ability to, tubeless in general gives you the ability to experience fewer flats without sacrificing cornering stability, rolling resistance, and general reliability from the tires themselves. Additionally, the SES road tires are hookless compatible. So some of our SES road wheels, like this is a 3.4 AR, has a hookless bead profile. So the SES road tires have been specifically designed to work with a hookless type rim. What that means is the tire's bead diameter and the bead stiffness. So that's the stiffness of the tire bead, or the amount of force it takes to stretch that. We've achieved a stiffness that will ensure that the tire bead will not stretch over time. So if you're running a standard SES wheel, like a standard 3.4, 5.6, 7.8, our disc wheel, they have a hook bead, and so the tire is compatible with them as well. As far as the performance metrics go for SES road tires, they're tubeless. They've been aerodynamically optimized to be paired with an SES wheel. That doesn't mean that they can only be run on an SES wheel. They're definitely compatible with other brands' aero wheels, and we've shown in our wind tunnel testing that pairing the SES road tire on a non-Enve wheel can also improve the aerodynamic performance of that wheel system as well. In addition, we looked at, because it's an SES product, we look at it from a holistic performance standpoint. So what that means is we're not getting hyper-focused on one singular myopic performance metrics, say like aerodynamics or rolling resistance or weight savings. We look at the collective of all those metrics and try to find the best balance for that, because ultimately what we've found is the most aerodynamic tires in the market, they may have this one metric, but they may lack in other areas. The most efficient rolling tires, so the tires with the lowest rolling resistance, are often very, very lightweight, and so they perform poorly in terms of puncture resistance. And so what we wanted to do with the SES road line was to create the most balanced tire with the performance, with inclinations towards the performance and the racing side of things. And so what you'll find with the SES road tire ultimately is, as I mentioned, they're aerodynamic, at least as aerodynamic or on par with the best tires out there in terms of aerodynamic performance. They're tubeless compatible both with hooked and hookless type rims. That also means you can run an inner tube if you want to. So it's not that you have to run them tubeless. You can still run an inner tube. Weight-wise, we achieve a very competitive weight, and we're only slightly heavier than the lightest tires on the market. From a puncture resistance standpoint, we have been able to achieve, with the use of a puncture barrier using a material called Vectron, we're able to achieve a very high puncture resistance, much higher than the tires that are lighter weight, and as well as even higher than some of the tires that are much heavier. And so from that standpoint, The SCS road tires are built to last and built to perform when you're out on the open road where there's debris and innumerable things that can cause flat tires. From a rolling resistance standpoint, this is another area where we look to achieve a very nice balance. So we wanted to be competitive as possible in terms of rolling resistance. We are not aiming to make the most efficient rolling tire in the world. Again, it's about balance. And so we fall pretty much mid-pack in terms of the rolling performance. But the reason for that is because, again, being a best-in-class rolling performance tire at this point, at this stage in the game with the technologies that are available, means that you're probably making a very lightweight tire that is much more puncture prone than what these tires are. So we opted for higher puncture resistance versus lower rolling resistance. And the thinking on that is effectively that the amount of time you're going to lose with a flat tire is much, much greater than the amount of time you'll gain running the lowest rolling resistance tire. So again, it's about striking a balance, and we feel like the SCS road tires deliver a well-rounded performance value proposition that will help you better enjoy the ride experience. So years ago, when we developed the 4.5 AR, we realized that there was a need for a testing protocol for tires to establish whether they'd be compatible or not with a straight sidewall or hookless design. We took it upon ourselves to develop a tire test in which we could qualify tires for use with hookless, road tubeless design. And so that testing protocol that we came up with includes a pre-stretch process where we take the tire sample and we inflate it to its max PSI, and it must pre-stretch for 24 hours just to get everything stretched and ready for measurement. The next day, or after that pre-stretching process has been done or performed, we move to a bead diameter and a bead stiffness test. So we just want to know what the manufactured measurement or diameter of the tire's bead is, and we also want to know how flexible or stretchy it is or is not. That's really important when you're looking at a rim that doesn't have a hook bead to contain it if it's designed to stretch. So we're looking to see what the bead stiffness is. And then the final test in that qualification process is a max inflation test, where we require that a tire achieve 1.5 times the max pressure rating of the system in order to be qualified or deemed compatible with a hookless design. So in the example of the 3.4 or the 4.5 AR, that wheel has a max tire pressure rating of 80 PSI, which means that any tire that goes on the compatibility chart or list for use with the 4.5 or 3.4 AR must get up to at least 120 PSI and hold that pressure. Over the years, we've collected a lot of data around tire bead stiffness and diameter in performing our tire compatibility testing. So this chart shows a data point for each test we performed. There's near 400 data points on this chart. So what we have is we've broken it into 3 basic zones. And you can see right in the middle what we call the sweet spot. So this is the zone in which the tire's bead seat diameter and bead stiffness exert minimal amount of force on the rim itself and promise to ensure tire retention on a hookless rim design. So tires in zone 1 effectively have a small bead diameter, which can exert a lot of force. So that's why a lot of the data points in there are in the red, yellow, orange, and light green zone. It's because those are the bead diameters that are exerting a lot of force on the rim itself. The result of that is that you're compressing the rim, which reduces spoke tension, which then leads to a rim that can be out of true and not as stiff as you might desire. If you move into zone 2, you'll see that the load of the rim goes much lower. That's because, so into the blue and light blue zone. The blue means that the load has been reduced. These are at a diameter that's a couple millimeters smaller than the ETRTO requirement for the rim. And so the tire is easier to install, but the bead stiffness itself is still sufficient to prevent the tire from stretching off the rim. Down in zone 3, you have very low compressive loads on the rim. You have an easy to install bead seat diameter, but the bead stiffness itself is quite low. And so these are what the original or traditional road tubeless tires kind of looked like. Bead material was kept to a minimum to keep the tires lightweight, but it was consequently a bit stretchy. So when your rim had a hooked bead, these tires would stay on the rim because they'd stretch and be caught by that hooked bead, and you would never really know that your tire wasn't actually sealed on the proper sealing surface because the hooked bead was preventing that from coming to light. When hookless came about, there was nothing there to catch these tires. And so these are the tires that would tend to blow off the rim at low tire pressure because the bead stiffness was so low. Even though the diameter was safe and good, the stiffness meant that the diameter would change over time, or if the tire warmed up, or depending on how much pressure was applied to the tire, it would eventually come off the rim. So just in summary, this chart just shows the range with which tire manufacturers have developed tires and sort of where that sweet spot is to ensure retention on a hookless type rim. Okay, so being an SCS road tire, aerodynamics are one of the key performance objectives of the tire, and these tires have been designed to complement our SCS road wheel line. One way to achieve aerodynamics is simply the shape of the tire. And so by making a tire taller, you effectively increase the depth of the wheel system, meaning from tire to the rim depth. The other way is with tread. And so we'll talk about that in a second. So the Enve SCS road tire features a hybrid shape that is neither a perfectly round design nor is it a very tall elliptical shape. It's designed such that it allows for smooth airflow transition from the tire to the rim sidewall. The other factor is tread. So what you'll notice on the Enve SCS road tires is they feature this unique tread pattern on the shoulder, which is what we call the breakaway tread pattern, which is a deconstructed Enve logo, consequently. And it's not so much what the tread pattern is, it's all about the shapes that are in the tread pattern. And what we're looking for are sharp edges and angles that trip the airflow so that it can accelerate across from tire to rim and then close on the back end. As the air is flowing over, it comes across the rim, back across the tread, and again, the tread pattern helps turbulate the airflow, accelerate it, and to close the wake as it leaves the trailing edge of the wheel. So the breakaway tread pattern is one of the key components to the aerodynamic nature of the SCS road tire. The SCS road tires also come in 4 sizes in 2 different colors. So you can see both the colors here. We have a black sidewall as well as a tan sidewall. Other than the colors, the construction and the rubber compounds are exactly the same. And then as I mentioned, they come in 4 different sizes. So we have a 25, which is designed for the standard SCS road wheels in our legacy products. So if you own an SCS wheel set that was purchased basically over the last decade, you're primarily going to be looking at the 25 as in terms of its ability to enhance your aero performance and be the optimal pairing for that wheel set. We also offer a 27, a 29, and a 31. So the 27 is going to be your higher volume race-oriented combination, which can be used on the hookless AR, SCS AR category wheels. The 29 is this tire right here. So again, a little bit higher volume, a little more proficiency for rougher roads and mixed terrain. And then the 31 is going to be truly for somebody looking for more comfort in a performance tire. So it's the same construction, but higher volume to be run on primarily our AR or G series wheels. On the back of each package, you will see a graphic. So this is for the 25, and what this shows is the actual inflated measurement of the tire when it's on one of the 4 different rim widths that we make. So every rim we make, or the different wheel models we make, also depending on generation, have different internal rim widths. So very early generation SCS wheels were as narrow as 17 millimeters. And if you go up to the current SCS 3.4 AR, that's a 25 millimeter internal. So depending on the rim that you're putting the tire on is going to determine the ultimate width or volume of the tire once inflated. So make sure you check the packaging as well as the website to see what the actual measured width of your tire will be, primarily so you know if it's going to fit inside your bike frame or not.